Hi everyone, welcome to my Max Academy. In this video, we'll continue with the chapter Determinants from your 12th standard CBSE Mathematics. I'll continue with the miscellaneous exercise in page number 141 in your textbook, problem number 5. Solve the equation, this determinant equal to 0. So it is given that the value of this determinant equal to 0, we have to solve and find the value of x. Solve and find the value of x. Now let's take this. So solution is, so it's given that determinant x plus a x plus a x plus a equal to 0. This is given. We have to solve and find the value of x. Now again we'll try to see whether we can get same elements in a particular row or particular column by adding all the rows or all the columns. Suppose if you add all the rows, right, you get x plus a plus x plus x will give you 3a plus x. Here also if you add all x plus x plus x, 3x plus a, 3x plus a. So we get the first row will become 3x plus a, 3x plus a, 3x plus a. Then if a particular row or a column has same value for all the elements, then that can be taken out of the determinant. Then it will become 1, 1, 1. Once we get 1, 1, 1, then we can easily make two of them as 0. Then we'll expand the determinant. So we will do the operation. R1 implies R1 plus R2 plus R3. So if you do this, then this determinant becomes 3x plus a, because x plus a, R1, R2, R3. Again R1 plus R2 plus R3 is R1. So 3x plus a, 3x plus a. So the other two rows as it is I am writing x plus a equal to 0. Now we'll take 3x plus a common. So you get 3x plus a, because it is present in every element of row 1. It can be taken out of the determinant. Then we get 1, 1, 1, x plus a, x, and x plus a equal to 0. Fine. Now we can make these two elements as 0 by doing this is C2 is C2 minus C1. Then this will become 0. Again, if it's C3 minus C1, then it will also become 0. Right? So we'll make the operation, column operation. So we will do the column operation as C2 implies C2 minus C1. So this minus this. Again C3 implies C3 minus C1. Right? So this becomes 3x plus a into determinant. Then first column no change, 1xx. This is 1 minus, second column is C2 minus C1. C2 is 1, C1 is 1. So 1 minus 1 is 0. Then x plus a minus x will give you a. X minus x will give you 0. Again 1 minus 1 is 0. C3 minus C1. C3 minus C1. X minus x is 0. X plus a minus x will give you a. So this is equal to 0. Fine. So now we'll take 3x plus a into, now let's expand this determinant along R1, because we got two zeros. So if you expand this, 1 into close this and this, a into a square minus 0, you'll get only a square, and that is equal to 0. And it is given that a is not equal to 0, therefore a square is not equal to 0, therefore we get 3x plus a equal to 0, because a is not equal to 0. Therefore, so you get x is equal to minus a by 3. So if you solve this, the value of x is minus a by 3. Fine. So all of you can pause the video and take the notes. I'll go to the next problem, which is problem number 6. So problem number 6 is, in the exercise, next problem is problem number 6 is prove that, we have to prove that determinant a square bc ac plus c square, then a square plus ab, then b square, then ac, then ab, b square plus bc, then c square. we have to prove that the value of this is equal to 4 times a square, b square, c square. So we have to prove the value of this determinant is equal to 4 times a square, b square, c square. Now again, so if I take this as delta, suppose we have to put delta equal to this. So solution is delta equal to, if I try to observe this determinant, right, you see that in the first column a is common in each element. A is here, A is here, A is here. Similarly, B is in second column, C is in third column. So I'll pull out A from the first column. So it will become A. Then this first column will become A because A is taken out. So A square will become A. Then here one A is out. So it will become A plus B. And here one A is taken out, it will become B. So similarly from the second column, I'm taking B out. Then it will become it will become C because B is taken out. B, then B plus C. Then from the third column, I'm taking C out. If I take C out, I'll get A plus C. Then it will be A, it will be C. Right? So we have got this determinant after taking A out of the first column, B out of the second column, C out of the third column. Now, again, we will try to see whether we can make maximum zeros as much as possible. So let's observe this. So we can make this as 0. We can make this element as 0 by doing this plus this. R2 is R2 minus R1 minus R3. Or we can even do R1 minus R2 plus R3. Any one of the things. So we will take this one. So I will take this is A plus B. From A plus B, if I subtract A and subtract B, this will become 0. So I'm going to change R2. Right? So how I'm going to write this? So delta is, so R2 implies R2, which is A plus B, R2 implies R2 minus R1 minus R3. If you do that, then your delta will become ABC of, then R1 there is no change, AC, A plus C. Then R2 is R2 minus R1 minus R3. So A plus B minus A minus B is 0. Right? Then B minus C minus B plus C. So B, that is R2 minus C, which is R1. So B minus C minus of B minus C. So your B and B will get cancelled. This is minus C, this is minus C. You will get minus 2C. Clear? If you do this, suppose if I write the rough one. So R2 is what? B minus R1 is minus C minus R3 is minus of B plus C, which will become minus B minus C. So they will get cancelled. Minus C is minus 2C. So similarly here, R2, A minus of A minus A plus C. So A minus C minus C, A will get cancelled. We will get minus 2C here also. Fine? Right? So A minus C will give you 2C. Then this is B plus C and C. Fine. Now again, if you observe, the second row has 2C common, minus 2C. That can be taken out. Right? So if you take out minus 2C, because this has 2C, this has 2C. So 0 also has 2C, because 0 can be written as 0 into 2C. 0 can be written as 0 into minus 2C. So minus 2C is common. So that can be pulled out. So if I take minus 2C out of the second row, so our delta will become ABC into minus 2C, which is taken out of row 2. So my determinant will become A, C, A plus C, 0, 1, 1, because minus 2C is taken out. Right? Or if you want to avoid negative, we can even take 2C common. So you get minus 1, minus 1. That is also fine. Right? Or we'll take with the minus. That's okay. So 1, 1, better to keep the minus here. Then B plus C and C. Fine. Now again, we have made 1 0. Can we make one more 0? So we can make this 0 by doing this is this minus this. Or we can make this as 0 by doing this minus this. So we choose this minus this. So which means C2 is C2 minus C3. So C2 implies C2 minus C3, which means this will become 0. So your delta will become ABC minus 2. I'll put minus 2 ABC square. If you multiply these two, then determinant. Column 1 no change. Column 2 is column 2 minus column 3. So C minus of A plus C. That will give you minus A. Then 1 minus 1 is 0. Then B plus C minus C will give you B. Then the third column is as it is. A plus C, 1 C. Fine. Now again, see the second row, these two have become 0 and this is 1. So we can expand along second row. So expanding along the second row R2, along R2. So if you expand along R2, what do we get? So we get delta equal to minus 2ABC square into, now this one, this is A21, A22, A23. So I should put minus 1 because the portion of this is A23. 2 plus 3 is odd number, means minus. I'm expanding along R2, minus 1 into. So we have to close this particular row and this particular column. So if you close this row and this column, right? If I close this row and this column, right? I don't have my scale here. Scale is here. So if I close this row and this column, you'll get A into B is AB. Then minus of A into B is plus AB. So finally we get minus 2AB square or BC square into AB is 2AB into minus 1 is minus 2AB. Now if you multiply all, minus and minus plus, 2 times 2 is 4, A square, B square, C square. That is your delta. That is your delta. So we have proved the value of this is equal to 4A square, B square, C square. Clear? So all of you can pause the video and take the notes. Fine. I will go to the next problem, which is problem number 7. It's important. So I'll erase all of these now. Okay, so seventh problem is, so what is given? So given is A inverse is given. So A inverse is equal to 3 minus 1, 1, minus 15, 6 minus 5, 5 minus 2, 2. So A inverse is given. Then B matrix is given. B is 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. Now we should find, so this is given. This is given. So to find, what we have to find? We have to find what is AB matrix whole inverse. We have to find AB matrix whole inverse. Right? Now solution. Now how do you find AB matrix whole inverse? Right? So we know one of the results in the inverse which we studied, that is we have AB whole inverse is nothing but B inverse into A inverse. If you want to find the inverse of a product of two matrices, that is equal to the product of the inverses of the respective matrices taken in the reversed order. Right? So AB whole inverse is not A inverse B inverse, it is B inverse A inverse. So to find AB whole inverse, we know A inverse, which is given here. If you find B inverse, B is given. If you find inverse of this matrix and multiply the inverse of this matrix with this, you will get AB whole inverse. Right? We can also try to see that we can do it in the other way, like we can find inverse of A inverse. Inverse of A inverse will give you A. Then inverse of A inverse. If you find the inverse of A inverse, it is A. So if you find the inverse of this matrix, you will get A matrix. Then this is B matrix. A into B, you do AB matrix. Again, you have to find the inverse of AB to get AB inverse. That way also we can do, but it's longer than the way that it's longer than using this result and then proving it. So we will find B inverse and then we'll multiply B inverse with A inverse because A inverse is given. So how do we find B inverse? Now B inverse formula is what? 1 by determinant of B into adj of B. Right? Let's find what is determinant of B. What is determinant of B? So we'll take 1 into, to expand along row 1, 1 into close this, 3 ones are 3, minus 0. Then minus 2 into, so this is 2, but the position of this is A12. 1, 2 means 1 plus 2 is odd. So we should put minus, then 2, we'll close this particular row and this particular column. Minus 1 into 1 is 1, minus 1, then minus 0. Then minus 2 into, this is minus 2, its position is A13, 1 plus 3 is 4, so it is even. So I am putting plus of this minus 2 is minus 2, close this particular row, this particular column, minus 1 into minus 2 is 2, then 0 minus 3 is 0. So finally you get 3, 2 into 1 is 2, this is minus 4 which is equal to 1 which is not equal to 0. So your determinant of B is 1. Now we should find adj of B. So inverse exists. Only the determinant of B is not equal to 0, inverse exists. So we can say B inverse exists. We can say B inverse exists because determinant of B is not equal to 0. Therefore, B inverse exists. And what is B inverse? B inverse is 1 by B inverse is 1 by determinant of B. That we have the formula here. I don't want to write the formula here. We'll find adj of B. What is adj of B? Adj of B is B11, B12, B13, B21, B22, B23, B31, B32, B33. So this is the adjoint of the B matrix where capital B11, capital B12 respectively are the cofactors of elements of matrix B. So let's find the cofactors. Now let's find B11. So I will put the column here. So now B11. So B11 is equal to, so B1 plus 1 is 2. 2 means even. It is equal to minor of M11. So minor of this matrix, this element 1. That will be close this. 3 ones are 3. Minus 2 into 0 is 0. So that will become 3 minus 0 which is 3. Now B12. B12 is minus M12. So 1 plus 2 is 3. 3 means you have to put odd number means you have to put minus. So take this element, close this, close this. Minus 1 into 1 is minus 1 equal to minus of minus 1 minus 0 which will give you 1. Then B13. B13 is M13. That is equal to, you have to take this element. Right? Then close this particular row, this particular column. So 1 into 2 is 2. Then 0 into 3 is 0 which will give you 2. So we have found B11, B12. So now let's find B21. That is minus M2 because it is negative. 2 plus 1 is odd. So M21. That is equal to, we have to take this particular element, right? And I will close this particular row and this particular column. So 2 into 1 is 2 minus 2 into minus 2 is plus 4. So 2 minus 4. You get minus of 2 minus 4 which is 2. That is your B12. Now B22. So that is B21. Now we should find B22. B22 is M22. That is equal to M22, this element. So we have to close this particular row and this particular column. So you get 1 into 1 is 1 minus 0 is 1 minus 0 is 1. Then B23 is equal to minus M23. That is equal to minus of M23. M23 means this particular element. So close this particular row, this particular column. 1 into minus 2 is minus 2. Then that is 0. So that is equal to 2. That is your B23. Now let's find B31. B31 is M31. That is equal to, now take this element, close this particular row, this particular column. 2 into 0, 0. Minus 3 into minus 2 is minus 6, so it will become plus 6. Then I will write here. Then comma. Okay, I'll write here only. B32 minus M32. That is equal to minus of M32. So M32 means we will close this part, this element. So close this particular row, this particular column. 1 into 0, 0. 0 minus 2 is 2. There is a minus here. Then B33 is M33. That is equal to M33. Close this particular row, this particular column. 1 into 3 is 3. Minus of 1 into 2 is minus 1 into 2 is minus 2. Minus of minus 2 is plus 2. So 3 plus 2 is 5. So you'll get 3 plus 2, which is 5. So that is your B33. Now let's put all of them. So what is our adjob B matrix? Adjob B is equal to, we have to substitute all this B11, B12, B13 here. So B11 is 3. Then B12 is 1. B13 is 2. Then B11 is, sorry, B21 is 2. 1, 2. This becomes 6, 2 and 5. This is our adjob B. Now what is our B inverse? B inverse is equal to 1 by determinant of B. Determinant of B is 1. So 1 by 1 into this matrix 3, 2, adjob B. 3, 2, 6, 1, 1, 2, 2, 2, 5. So which will give you the matrix as the same matrix 3, 2, 6. We have 1 by 1 is 1. So 1, 1, 2, 2, 2, 5. So this is your B inverse. Now we should find B inverse into A inverse. Now what is B inverse into A inverse? So our AB whole inverse is B inverse into A inverse. So B inverse is this matrix 3, 2, 6, 1, 1, 2, 2, 2, 5 into A inverse. A inverse is the given matrix 3 minus 1, 1, 3 minus 1, 1, minus 15, 6 minus 5, then 5 minus 2, 2. So that is your A inverse. So A inverse is this. That is A inverse. And B inverse is this. So we should multiply these two. We should multiply these two. So what do we get if you multiply? So 3 into 3 is 9. Then 2 into minus 15 is minus 30. Then 6 into 5 is plus 30. Then first row with first column. Then first row with second column. 3 into minus 1 is minus 3. Plus 2 into 6 is 12. Then 6 into minus 2 is minus 12. Then 3 into 1 is 3. 2 into minus 5 is minus 10. 6 into 2 is plus 12. Fine. So next 1 into 3 is 3. Then 1 into minus 15 is minus 15. 2 into 5 is 10. Then 1 into minus 1 is minus 1. 1 into 6 is plus 6. 2 into minus 2 is minus 4. Then 1 into 1 is 1. 1 into minus 5 is minus 5. 2 into 2 is plus 4. Then 2 into 3 is 6. Plus 2 into minus 15 is minus 30. Then 5 into 5 is 25. Then 2 into minus 1 is minus 2. 2 into 6 is 12. 5 times minus 2 is minus 10. And 2 into 1 is 2. Plus 2 into minus 5 is minus 10. 5 into 2 is 10. Fine. So finally, what are we going to get? So we are going to get, if you simplify, this will become 9. This is 12. This will become minus 3. This 15 minus 10 is plus 5. Then here minus 5 plus 3 is minus 2. Here you get 1 because minus 5 plus 6 is 1. And this becomes 0 because 1 minus 5 plus 4 is 0. Right? Then this becomes 1. 30, this is 31, and this becomes 0. And this becomes 2. 102. Right? So your inverses, AB inverses, this matrix 9 minus 3 5. This is 5. So the AB inverse is 9 minus 3 5 minus 2 1 0 102. So this is the inverse of AB inverse. So this is how we will find the AB inverse. Fine. So all of you can pause the video and take the notes. I will end the session here. You can watch my next session for the continuation of this. Thank you for watching. See you all in the next video. Thank you.